Hello class, and welcome to section 5.2, which is about piecewise-defined functions. By the end of today's lesson, you will be able to graph, write, and apply piecewise-defined functions. So a piecewise-defined function is a graph that has different rules for different intervals of the domain. So what it's basically saying is we can piece together different sections of the graph to have an entire graph all together. So we were looking at absolute value functions, so you'll see that right here. But you'll notice with an absolute value function that it's coming down and then it takes a hard turn to go back up. So there's kind of two distinct portions of the graph. So we learned that this absolute value function here would be f of x is equal to, and then we go up 2 and over 1, so is equal to 2 times the absolute value of x. What piecewise functions do is it says, okay, let's break it into its pieces, so its parts. In this case, it's going down, down, down. It stops at 0, so that's where we would split the graph, and then it starts going back up. So if you look at this first function, it's actually going down 2 and over 1. So that first part of the graph would be the equation negative 2x for this first side of the graph. The second side of the graph is where it goes up 2 and over 1. The absolute value takes care of this positive and negative, but there's two different parts of the graph. So if we wrote it out as a piecewise function, we would say f of x is equal to these two things. And we would also define when the change happens. So this first part is happening when the x values are smaller than 0. The second part is happening when the x values are greater than or equal to 0. It's going back up after we hit that x equals 0 mark. So the absolute value function can be broken down into a piecewise function. It's two different parts. So the first thing we're going to talk about is how do we graph these. So we have the piecewise function that says f of x is equal to x plus 1 when x is less than or equal to 2. And then negative 3 over 2x plus 6 when x is greater than 2. So that means that 2 is our changeover point. So that's going to play an important role in how we graph this. For the first part, we are going to go ahead and say, okay, so 2 is where our changeover happens. So I'm going to plug 2 in for x. So I've got 2 plus 1 is 3. So that means a point on that first line is going to be 2, 3. 2 is included in that, so I'm going to go over 2, up 1, 2, 3, and that's going to be a dot because it's equal to that number. Now, it also says that this happens when x is less than or equal to 2. So we need a number that's smaller than 2. I'm going to use 1. So I'm also going to plug 1 into that equation. So 1 plus 1 is equal to 2. So another point on this first part of my graph is going to be 1, 2. So I'm going to come over and graph over 1, up 1, 2. That is going to be enough to get my first part of my piecewise function. So I'm going to take and I'm going to draw the first part of my graph. Notice I started at the first point. So I started at the 2, 3, that first point that I graphed, and then I then I went through that second point. So the first part of my graph, the x plus 1 for x is less than 2, is this first line. Then I need to solve the second part. So I'm going to take, and I again have 2, so I'm going to start by negative 3 over 2 times 2 plus 6. Negative 3 times 2 is negative 6, divided by 2 is negative 3, plus 6 gives us an answer of 3. So our first point for the second half of our graph is also going to be 2, 3. Now, because this doesn't have the equal to part, I don't put a dot, but I've got my open dot there. Now we need something bigger than 2. So something bigger than 2, I could say 3, but if I do negative 3 over 2 times 3, I'm going to end up with a decimal. So when I'm picking points, I like to pick things that are going to come out to whole numbers. So I'm going to jump up to 4 because 4 is bigger than 2. And when I do negative 3 times 4, I get negative 12. Divided by 2 is negative 6. Plus 6 is equal to 0. So that means another point on my graph is going to be at 4, 0. So I can come over 1, 2, 3, 4, and 0. Again, you're going to take and you're going to connect those points now, starting at the first one you graphed, so starting at 2, 3, and then going through that second point you graphed, which was 4, 0, and continuing your line. And that gives us our piecewise function. The line on the left is represented by that first equation, and the line going to the right is represented by the second equation. Go ahead and try this one on your own. So you're going to plug in first, you're going to plug in 1, and you're going to get 1, negative 1. That's that first point right here. Then I need a number smaller than 1. So I'm going to plug in 0, and that gives me 0, negative 2. That's that second line. Starting at the first point, going through the second one gives you that first line. For the second one, I've got plugging in 1 first. That's going to give me the point 1, 1. That's going to be an open dot because there's no equal to part. And then I need something bigger than 1 to plug in. So I'm going to plug in 2, 2, negative 1, get that second dot, and drawing your line through that. Notice, in the first one, our point was the same. So our graph was touching when it started. It is okay for piecewise functions to have this gap. They do not have to have both lines touching like this. They can be starting from 2 different points. The next thing we're going to talk about is writing piecewise functions. First, we're going to relate it specifically to that absolute value example that I showed you on the first slide. So if we have write f of x is equal to 9 absolute value of x as a piecewise function, we're going to need to split it up into 2 parts. First, you're going to want to visualize 9 absolute value of x. So we know that the absolute value function goes up like this, and then we want it to be multiplied by 9, so it's going to get narrower. When you are writing your piecewise function then, we have f of x is equal to, and then we're going to use that bracket, the one that I have difficulty drawing. Again, that is your shift key, and then the bracket is next to the P, so shift, and then that key next to P is going to give you that bracket. And now we need to figure out, for the first part of our graph, notice with the absolute value, that would be trending down. So it's going to be the negative version of that, so the negative 9x, and that's for x is less than 0. That's that first half of your graph as it's going down. Absolute value functions have their origin at 0, so that's why it flips over at 0. Then we flip up, and we're going up now, so that's that positive part of your absolute value graph, and that's going to be for x is greater than or equal to 0. So that's where it's trending up. Go ahead and try this one on your own. So now that we've got the negative 7 here, that means that absolute value graph is going to be flipped upside down. So that first part, where x is less than 0, is actually the part that's trending up. So we've got 7x when x is less than 0. Then for the second part, after we hit 0, our graph is now trending down. So that's where we get the negative 7x for x is greater than 0. So that's how we write the functions when we have those absolute value piecewise ones. We can also write piecewise functions when we are given the graph. So what we're going to do here, I always start with the one that's on the left. And the first thing I do is I'm going to go ahead and identify where the change happens. So I'm looking here and I see that the red line is going until it hits this purple part, and then we switch to the blue line. So that means that the change is going to happen at x is equal to 2. So something is happening when x is smaller than 2, as something is happening when x is bigger than 2. We're going to start with the smaller part, so that red line. First thing you're going to want to do is find the slope. So if I'm looking at this red line, I can see a couple of different points on here. I've got this one, I've got this one, I've got, where's another one? This one. So all of these, I'm going up 2 over 1, up 2 over 1, up 2 over 1. So that means for my red line, my slope is going to be 2 because it's 2 over 1. And then I need a point that's going to help me figure out the rest of this equation. I'm going to use the point that they give us, so 2, 1. Now I need to find the y equals mx plus b equation. So I'm going to go ahead and plug in, and I'm going to say that y equals 2x plus b. Then you can plug in your x and your y. So we're going to get 1 is equal to 2 times 2 plus b. 1 is equal to 2 times 2, which is 4, plus b. Subtract 4 from both sides, and you get negative 3 is equal to b. So that equation for the red line is going to be y equals 2x minus 3. So now looking at that blue line, we're going to pick out again some points on that line. So we're going down 3 over 1, down 3 over 1, down 3 over 1. So that means our slope for that blue line is going to be negative 3 over 1, or just negative 3. And then I'm going to use that point again, so that's going to be 2, 1, 2, 3, 4. So my point here is 2, 4. The other way that you could have gone about solving for this equation is you could have used your point-slope form. So this being x1 and y1, you could have said y minus 4 is equal to your slope, so negative 3 times x minus 2. Use the distributive property on the right side, so you get y minus 4 is equal to negative 3x. Negative 3 times negative 2 is plus 6. And then we're going to add 4 to both sides of the equation. And we get y is equal to, for that blue line, oopsies, add 4 to both sides. And then your blue equation is going to be y is equal to negative 3x plus 10. So you can either use slope-intercept form and solve for b, or you can use point-slope form and use the rearranging. Either way is fine. You will still get to the same equations. So what that means then is your piecewise function, the final answer for this equation, is going to be f of x is equal to, then we've got our bracket, and that's going to be 2x minus 3y. So the red line happens for the x values that are less than or equal to 2, because it has that filled in dot, and 2 is our changeover point. Then the other part of your function is negative 3x plus 10 when your x values are greater than 2. So when you hit 2 and you get bigger, anything bigger than 2, you're going to plug into that second equation. Go ahead and write the piecewise function for this graph on your own. So on the red line, we've got our slope is up 3 and over 4, and our point that they give us is 4, -4. Plug that in and solve. You get y equals 3/4 x minus 7. You could have also done slope-intercept if you preferred that. For blue, your slope is down 3 over 1, so -3, and your point is 4, -5. Plug that in and you get a b value of 7. You also could have used that point slope form to solve. Your changeover point here is that x is equal to 4. So that means your final function is 3/4 x minus 7 when x is less than or equal to 4. That's your red line. And then -3x plus 7 for x is greater than 4. That is your blue line. The last thing here is we're going to use a piecewise function to apply it to some word problems. So it says a gym owner wants to purchase some custom wristbands for a marketing promotion. She thinks they will need about 75 wristbands. Her assistant is insisting on ordering over 100 bands because it is cheaper. How can the assistant convince the gym owner this is true? So your first job, if you're going to apply a piecewise function, is to write a piecewise function. So we've got f of x is equal to, and then we need our function. We need to translate what they have here into a function that we can solve. So it says 0 to 50 wristbands, $2 each, plus $20 for shipping. We know that each, that's that multiplication word for our variable. So we have $2 each plus the $20 for shipping. And that happens if you purchase 0 wristbands, all the way up to if you purchase 50 wristbands. So anywhere from 0 to 50 gets included in that first equation. Then the second part says 51 to 100 wristbands. The price is $1 each, so 1x, or just x, plus the $10 of shipping. And that happens when we start at 51 and go up to 100. There's a third option in this one. So we have our piecewise function being that it's 50 cents for each wristband plus nothing for shipping. And that is when we have x is greater than or equal to 101 because it's over 100 wristbands and the first amount you could purchase over 100 is 101. Now, we're looking at purchasing 75 wristbands. The first thing, so if we're purchasing 75 wristbands, that's going to fall into our middle category. So we would plug 75 in for x. So 75 plus 10 is equal to $85. So if we buy 75 wristbands, it's going to cost us $85. Now the assistant is saying that we should purchase over 100. So we're going to plug that then into the bottom one. So 0.50 times 101, and that, when you plug it into the calculator, is going to be $50.50 for 101 wristbands. So this is how the assistant could prove to the owner that it is cheaper because purchasing a greater amount has a lower price. Using that same piecewise function that we just wrote, what is the cost difference between one order of 200 wristbands and 2 orders of 100 wristbands? Go ahead and try this on your own. So the first option, 200, that's going to go into the bottom function. So 50 cents times 200 plus that $0 shipping gives you $100 for the 200 order. 2 orders of 100, you're going to plug that into the middle function. So $1 times 100 plus $10 for shipping is $110 for one order, times 2 gives you 210. To find the difference, 210 minus 100 is $120. If you have questions about this or anything else from the lesson, please let me know when you get to class.